Sorry. Yeah, 46th question. So in the circuit diagram, shown two resistance wires A and B are of same area of cross section, same material, but A is longer than B. Which ammeter, A1 or A2, will indicate higher reading of for current? Give the reason. So circuit diagram, if you observe, so here we have greater resistance and here we have less resistance. Not, I mean, length of the resistance. So here length is greater, here length is least, and they have connected an ammeter which is A1. They have connected another ammeter A2. So they are asking which ammeter will be showing greater value, which ammeter will be showing least value. So here we know resistance is directly proportional to length. Means when length increases, resistance also increases. When resistance increases, automatically rate of flow of charges, that is current, will decrease. When current is decreasing, automatically ammeter value will be less. Next, when length is decreased, when length is small, resistance also decreased. When resistance is decreased, automatically amount of current, rate of flow will increase. When rate of flow is increasing, automatically ammeter will show greater value. Here, first wire, this first wire has greater length, this second wire has least length. So because of greater length, ammeter will show least reading. Second one, because of least length, ammeter will show higher reading. So this A1 will show least reading, A2 will show greater reading. So here answer you can find length of A is greater than B, area of cross sections A and B is same. Therefore, resistance of A is greater than resistance of B. So current in A is less than current in B. Hence, A2 will give higher reading. So A2 will be giving higher reading and A1 will give least reading. Like that you have to write. Next, 47th question. Mention the condition under which charges can move in conductor. You see, we know conductor is nothing but conductors are the materials which will be allowing current to pass through it. So what are the necessary conditions needed to move charges in conductor? Name the device which is used to maintain the condition in electric circuit. You see, when potential difference is applied across two ends of the conductor, charges will move in the conductor. You see here, consider we have a bulb. Now here, let us take one wire here and let us take another wire here. Just if you connect wire to the bulb, you cannot observe glowing. Current cannot be passed. So if you want to pass current, if you want to allow electrons to flow through it, what we have to do? We have to connect one battery to it. So if you connect wire to the battery, then you can observe this bulb will be glowing. Why? Because what is the use of cell or battery? Cell is the device which will be maintaining potential difference across the terminals. Potential difference is nothing but voltage V. So we need to give some potential difference to move those free electrons. That is the answer. And they have asked which device will be maintaining, that is cell or battery. Cell or battery is the device which will be maintaining potential difference. Like that you need to write. Then we have 48th question. How would the reading of voltmeter change if it is connected between B and C? Justify your answer. Okay, if you observe the circuit diagram, here we have one resistor, next resistor, next resistor. First resistor value they have given it as 1 ohm, second resistor 3 ohm, third resistor 2 ohm, and resistor values are different. Now voltmeter is connected between this A and B. I mean voltmeter is connected to 1 ohm resistor. Next, what they are asking, if it is connected between B and C, means by removing this voltmeter, if you connect voltmeter to 3 ohm resistor, so that is indirectly they are asking what happens to the voltmeter reading they are asking. So it is quite simple. Let us try to calculate voltage value. Now circuit is given. Here R1 value is 1 ohm, R2 value is 3 ohm, R3 value is 2 ohm, which is connected to 3-volt battery. When you see 3 resistors are there which are connected in series. So 1 plus 3 plus 2, 4 plus 2, 6. So R value we got it as 6 ohm, and V value they have given in the diagram, that is 3 volt. Now it is easy for us to find I value. I is equal to question mark. We know Ohm's law, V is equal to I into R. If you need I is equal to V by R. V value is 3 and R value is 6. 3 ones, 3 twos. So that is I value is equal to 0.5 amp. So when 3 volt is passing through this circuit, current is produced, that is 0.5 amp. Now they have connected voltmeter here, means here simply to say this is series circuit. In series voltages will differ. Voltage at first resistor is V1, voltage at second resistor is V2, voltage at third resistor is V3. If you can find V1, V2 values, now it will be easy for us to say what happens to the voltmeter reading. Will it increase or will it decrease? Now let us try to find V1 value. We means try to apply Ohm's law to first resistor. V1 is equal to IR1. V1 value we don't know, that is equal to I value is 0.5 multiplied with R1 value is 1. 0.5 into 1, that is 0.5 only. So 0.5 volt. Now try to find V2 value. V2 is equal to IR2. That is equal to I value is 0.5 multiplied with R2 value is 3. That is equal to 3 5s 15, 0 and 1.5 volt. You see, V1 value is 0.5 volt, V2 value is 1.5 volt. We can tell V2 value is greater than V1. Hence, what happens to the voltmeter reading? Voltmeter reading will be higher voltmeter reading will be higher when it is connected between these 2 points. That is the answer we have to write. Next, in 49th question, they are asking same question. Same 2011 they have asked, and this question, yeah, same question repeated here. Leave it. Then 50. Tungsten is used almost exclusively for filaments of electric bulb. List 2 reasons. So these 2 reasons compulsorily you need to remember. Number 1, that tungsten has high resistivity. Tungsten has high resistivity. Number 2, it has very high melting point. So that only if you are passing continuous current through the bulb also, because of the high resistivity, it is generating some heat energy as well as it is generating some light. Because of that one, bulb is glowing. Number 2, it has very high melting point, so that only it will not break. These are the 2 reasons. 51. 3 VI graphs are drawn individually for 2 resistors and their series combinations. Out of A, B, C, which one represents the graph for series combination of other 2? Give reason. Okay, so they are telling like some VI graph is there drawn individually for 2 resistors and their series combination. Out of A, B, C, which one represents the graph for series combination? They are asking. You see, more slope of VI means more resistance. Slope C is maximum, hence resistance is maximum. So for series combination of 2 resistors, it is quite simple to understand this. Whenever VI graph is given, when the slope is maximum, that indicates series. And if the slope is minimum, that indicates parallel. Why? Okay, let me tell you with one example. Let us take 3 resistors. R1 value is 3 ohm, R2 value is 3 ohm, R3 value is 3 ohm. Let us try to connect these resistors in series as well as in parallel. And let us try to find R equivalent value. R equivalent, R series is equal to R1 plus R2 plus R3, which is nothing but 3 plus 3 plus 3. So R equivalent value we will be getting it as 9 ohm. If you connect in parallel, 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. Now 1 by R is equal to 1 by 3 plus 1 by 3 plus 1 by 3, which is equal to LCM for 3 is 3, 1 plus 1 plus 1 numerator, which is nothing but 3 by 3, cancel, we'll be getting 1. So when resistors are connected in series, value is 9 ohm. When resistors are connected in parallel, value is just 1 ohm. So by this we can conclude, if the slope is maximum, then that is series connection, and if the slope is minimum, that is parallel connection. Here if you can observe, there are 3 slopes. This is A, this is B, this is C. C is maximum, so that is connected in series. In question, if they ask which one is connected in parallel, you can write it as A. 52nd question. State the factors on which resistance of a cylindrical conductor depends. How will resistance of conductor change if it is stretched so that its length is doubled? Now, you see, they're asking state the factors which resistance of cylindrical conductor depends. We know resistance directly proportional to L, and resistance is inversely proportional to area of cross section. So resistance of cylindrical conductor depends on its length and area of cross section. These are the 2 necessary conditions. When conductor is stretched, its radius decreases, but the volume of conductor in the both cases will be same. Okay. Now consider we have conductor like this. What they are asking, how will resistance of conductor change if it is stretched so that its length is doubled? Now we have one resistor, I mean cylindrical resistor we have. Try to apply some force and try to stretch this. If you stretch that length, now here length is L, now length should become 2L it seems. You see, if it is stretched automatically, what will happen? That thin conductor will become, I mean that thick conductor will become thin. Means if it is stretched, automatically this radius will decrease. It will not be this much thick. This radius value, R value will be decreased, right? Means area of cross section is decreased. Now here you can observe L2 is nothing but 2L1. I mean this L2 is not, if the length of conductor is L1, L2 is nothing but 2L1, twice of first length. Now L1 is length, area of cross section is A1, now which is equal to L2 and A2. Now it has become L2 A2. Now what is L1 value? L1 only. What is A1 value? A1 only, is equal to what is L2 value? L2 value is 2L1. And what is A2? A2 we know that will be reduced, right? So let us try to find that A2. A2 we have to find. If you want to find A2, what we can do? L1 will be cancelled. We will get A1 is equal to 2A2. Send that A2 that side, it becomes A1 by A2 is equal to 2. Now we know resistance is equal to rho L by A. That is the formula. R is equal to rho L by A. In first condition, R value is equal to R1. Let us keep it. That is equal to rho value, because same material they are taking. So rho value will be rho as usual. Rho, what is length value? L1 upon what is A value? A1. This is for first case. Well, coming to second case, same formula we'll use. R is equal to rho L by A. And what is the second resistance? We don't know. Definitely it will be changed. So that let us mention it as R2, which is nothing but rho value will be rho as usual. And L value is nothing but 2 L1 by A value is nothing but A2. That's it, na? This is second condition. For first condition, R1 value is R1, L value is L1, A value is A1. Second condition, R value is R2, L value is 2L1, A2 we'll mention. We have got A2. We'll write that one. Now that is equal to, now this if you can see, R2 is equal to, what we can do is, okay, we can take ratio. We can take ratio R2 by R1. What is R2 value? Rho 2L1 by A2 upon R1 value is rho L1 by A1. Now numerator denominator, if you see rho 2 L1 by A2 multiplied with, if this is going to numerator, it will be reciprocal A1 by rho L1. Numerator rho, denominator rho, numerator L1, denominator L1 will be cancelled. 2 into A1 by A2 we will get 2 into A1 by A2. Now if you observe, A1 by A2 is nothing but 2 na. So instead of A1 by A2, what we can substitute 2? It becomes 2 into 2, which is nothing but 4. So R2 is nothing but 4 times R1. Or simply to say, in in-text question also we have discussed this. I mean example 12.6 or 12.5, I guess 12.6, I guess. Same question we will be getting. So no need of this much expression, but this is also another way which we can do that one. Next, then question number 53. A, what material is used in making the filament of electric bulb? Tungsten. B, name the characteristic which makes it suitable for these two characteristics, high melting point and another one, high resistivity. Same questions, it will be repeating. Theory, they don't have any scope to ask in electricity. So tungsten, high resistivity, high melting point, that's it. 54. How are ammeters and voltmeters connected in circuit? What do they help us measure? So we know always ammeter is connected in series. Ammeter always it is connected in series, and ammeter is used to measure current. Voltmeter always it is connected in parallel, and it is used to measure voltage in the circuit. Next, 55. In 2010 they asked, the following table gives the resistivity of 3 samples. There are 3 samples, A, B and C. A resistivity, okay, A, B, C. A has 1.6 into 10 to the power of minus 5, B 5.2 into 10 to the power of minus 5, C 100 into 10 to the power of minus 4. Okay, here most of the students, what they will do, they will see this 1.6, 5.2 and 100, but most of the cases we have to see this one, 10 to the power of, that powers we have to see. Okay, which of them is suitable for heating elements of electrical appliances and why? You see, they are asking, indirectly they are asking, read between the lines, which of them is suitable for heating elements of electrical appliances? If you wanna use a material as a heating effects of electrical appliances, that must be high resistive. That must be high resistive. In this, which one is high resistive means definitely we can tell. You see, this is 10 to the power of minus 4, 10 to the power of 5, this is 10 to the power of 4, and 100 into 10 to the power of 4 is the value which will be giving high resistivity. So sample C is obviously used for making heating elements. Next, 56th question. Give reason why tungsten is a stupid question. Every time they will be asking, leave it. Already we have discussed. High resistivity, high melting point. That's it. Okay, 57. B1, B2, B3 are 3 identical bulbs connected as shown in the figure. Okay, if you observe the figure, what they have given here, there, there is an ammeter A1 and bulb is connected, and here second bulb is connected, and here we have ammeter. Don't get confused, don't get confused. And here third ammeter A3 and bulb is connected here. Just by seeing the diagram, most of the students will be like, okay, this question is somewhat difficult, let me leave that. Don't leave. And one battery, okay, key and ammeter. So this ammeter is for entire circuit, A1, A2, A3, 3 ammeters for individual bulbs. That's fine. When all 3 bulbs glow, a current 3 amp is recorded by the ammeter A. Okay, this ammeter is recording current I is equal to 3 amp. That's fine. A, what happens to the glow of other 2 bulbs when bulb B1 get fused? You see, this is B1, this is B2, This is B3. So if B1 is fused, if it is not working, what happens to remaining two bulbs? They are asking. Already we have discussed in parallel connection. That is a good advantage of parallel connection. If one component is not working, other two components automatically will work because of current division. There is no voltage drop, as well as there will be good current division. So that if bulb 1 is fused, B2, B3, automatically it will work. Nothing will happen to that. B, what happens to the reading A1, A2, A3 and A when bulb B1 get fused? You see, when you see the other two bulbs will glow, even B1 gets fused, there is no change in glow B2, B3. That's what we have discussed. That is the advantage of parallel connection. And here V is equal to 4.5 volt. Why? How we got V is equal to 4.5 volt? Did they give any information here? So only 3 amp they have given. Okay, diagram there must be mentioned. Okay, it might be printing mistake. 4.5 volt. Okay, V is equal to 4.5 volt and I is equal to 3 amp. Now if you try to find R value, we know V is equal to IR. R is equal to V by I. 4.5 upon 3. 3 ones, 3 1.5. So R value we got it as 1.5 ohm. And for parallel connection, whatever you do, we will be getting for B2 I value, means this is B2 na, which is connected in parallel na. If it is connected in parallel, V value will be same 4.5, but I value it will be I2. And what is R value? R value is same, that is 1.5. Now we have to find I value. We know V is equal to IR, I is equal to V by R, V value 4.5 upon R value is 1.5. Right. So 4.5, 1.5. Why they have given 4.5 is equal to R value 4.5. Oh, resistance in parallel 1.5, which is equal to, okay, 3 resistors, 3. Okay, these 3 bulbs connected in parallel, so that we have to take resistors of each bulb. If you do it, and we'll get resistor of each bulb is 4.5 volt. So R value is also 4.5, which will be cancelled, and I2 value will be 1 amp. When I2 is 1 amp, let us go with the I3. I3 also will be 1 amp. So ammeter values will not change in this case. Like that we have to mention. 58th question. A, draw a circuit diagram to show how two resistors are connected in series. Okay, however we want, we can draw two resistors in series. Like that we can connect. In a circuit, if two resistors 5 ohm and 10 ohm are connected in series, how does the current passing through the two resistors compare? So if this is 5 ohm and this is 10 ohm, and if there is some battery, what happens to the current? In series, currents will be constant. That's it. Current remains same. So your answer you can see, in series combination resistances, the current remains same. If they ask about voltage, voltages will differ. Near 5 ohm resistor, voltage will be V1. Near 10 ohm resistor, voltage will be V2. That is the answer you can write. 59. A bulb rated at 5 volt. So voltage value is equal to 5 volt. 10 milliamp. I value is equal to 100 milliampere. Calculate power. P is equal to, we have to calculate, we know V into I. Resistance R is equal to question mark. So we know Ohm's law, V is equal to IR, and R value we can find it as R is equal to V by I. Now P is equal to V value is 5 multiplied with I. So I value directly we cannot take 100 because it is 100 milliamp. So milli, in the sense I told you already, it is 10 to the power of minus 3. So 100 milliamp means 10 into 10 to the power of minus 3. So 5 into 100 into 10 to the power of minus 3, which is nothing but 5 into 100, 500 into 10 to the power of minus 3. So now what we can do, 500 10 to the power of minus 3 means 1 by 10 to the power of 3, means by 1000. Two zeros will be cancelled. 5 by 10, 5 by 10 is nothing but 0.5. So power value P is equal to 0.5 watt. That is the SI unit of power. And we have to find R value. We know Ohm's law. V is equal to IR. R is equal to V by I. V value is equal to 5 volt upon I value is equal to 100 milliamp, 100 into 10 to the power of minus 3. So this can be written as 5 by 100 multiplied with 10 to the power of minus 3. If it is going to numerator, it becomes 10 to the power of 3. Now 5 by 100, 5 by 100 means 0.05 multiplied with 10 to the power of 3, means this point will be going 3 places, 1, 2, 3. So simply to say, we'll be getting 50 ohm. R is equal to 50 ohm. Next, 60. An electric bulb draws a current of 0.2 amp. So I is equal to 0.2 ampere. When the voltage is 220 volt, V value is equal to 220 volt. Calculate the amount of charge flowing through it in 1 hour. So Q value is equal to question mark and time T value is equal to 1 hour. Right. So we can calculate this. So we know I value is equal to Q upon T, and Q we need to find. Q is equal to I into T. What is I value? 0.2 into T value is 1 hour. 1 hour means 60 minutes multiplied with 60 seconds. So that is equal to 0.2 multiplied with 663600 and 0.2 3600, or what we can do, 3600 multiplied with 2, you can get it as 0.06212 7200, but there is point here, so answer will be 720. So Q value is equal to 720 coulomb. Like that you can write it. We have 2 questions, we will complete that. 61. An electric iron draws a current of 0.5 amp. I value is equal to 0.5 amp when the voltage is 220 volt. V value is equal to 220 volt. Calculate the amount of electric charge flowing through it in 1 hour. Right, same question. So calculate the amount of electric charge. Q value is equal to question mark flowing through it in 1 hour. T is equal to 1 hour. And we know current I is equal to Q by T. Q value is equal to I into T. And I value they have given it as 0.5. So 0.5 for easy calculation, we can mention it as 1 by 2 multiplied with T value is 1 hour, 60 into 60. So this can be written as 1 by 2 multiplied with 663600 2 1s 2 2 8 1600. So we will get answer Q is equal to 1800 coulomb. Next, same type of question in 2004. An electric appliance draws a current of 0.4 amp. I value is equal to 0.4 amp when the voltage is, so voltage is unnecessary data, 200 volt. Then calculate the amount of charge. Q value is equal to question mark in 1 hour. T is equal to 1 hour. So what we can do, we know current formula. Q is equal, I is equal to Q by T. We have to find the Q. Q is equal to I into T. I value is 0.4 multiplied with T value is 1 hour 60 minutes into 60 seconds. That is equal to 0.4 multiplied with 663600. So what we can do, 3600 multiplied with 4, 0 0 6 4 is 24, 4 3 is 12, 13 14, 1 4 400. But here we have a point, so here we need to place one point. So answer will be Q is equal to 1440 coulomb. So these are the 2-mark questions, and in next lecture we are going to see 3-mark questions.